Hi, this is Mr. B, and today's video we're going to talk about converting repeating decimals to fractions. Now keep in mind, this lesson is meant as a supplement to my classroom lessons. It's not intended as a standalone product. So, to convert a repeating decimal to fractions, we have a very formulaic, a robotic way or a procedure way that we can do this, almost like if you were programming a computer. However, I know that can be really confusing. So there's 5 steps. Write them down. Pause the video if you need to, and if you need more time to write them down. And then we're going to look at an example. And then we'll talk about exactly how to do it. And you'll see that you don't really need the robotic steps anymore. But it's good to know what the exact specific steps are. Okay, let's get started. And again, don't worry too much about these first method. The second method is exactly the same method. It's just we kind of get more of a gut feeling on how to do it. So step 1 is we're going to set our variable n to be the repeating decimal. So whatever your repeating decimal is, we're going to call that the variable n. And step 2 is we're going to set p to be the number of repeating digits. So if there's 4 digits that repeat, then p is 4. If there's 2 digits that repeat, then p is just 2. And if it's only 1 digit that repeats over and over again, then p is just 1. It's real easy. Now, this next one looks really complicated, but it's not. We're going to take n times 10 to the p minus n. And n is your repeating decimal. We're going to take it and multiply by 10 to the p, basically moving the decimal point p places to the right. And then from that, we're going to subtract the original repeating decimal. And what this does is it gets rid of the repeating part. And we're going to set that and call that variable t for top. I would have used n for numerator, but I've already used n to represent our repeating decimal. Step 4 is we're going to take d for denominator, and we're going to set that equal to 10 to the p minus 1. Basically, if you moved it over 2 digits, we're going to take 10 to the second minus 1, which is 99. And so you'll end up, d will always be the number of 9s as how many repeating digits there were. So if you had a 3-digit repeating number, d will be 999. If you had a 1-digit repeating number, then d will be 9. So now we take the fraction t over d and simplify it. And when I say simplify it, usually you can't reduce it, but you need to make sure that there are no decimal points in the fraction. And we'll take a look at that. So let's get ready for an example. So I'm going to put in the top left, I'm going to put these steps 1, 2, 3, 4, 5, so we can reference them. So here's the steps, 1, 2, 3, 4, and 5. Just getting them written up there real quick. And we will reference them. You'll notice I'm color coding stuff. And so our first step is to set n to equal to our repeating decimal. Now I just picked this random repeating decimal, and you will notice the repeating decimal is 3.108, and the bar over the 08 means the 0 and the 8 repeat. Now the next step, p is equal to the number of digits that repeat. Since 0 and 8 are repeating over and over again, that means there are 2 digits repeating. Now we're going to take n times 10 to the p minus n and set that equal to t. So t is equal to 310.808 bar repeating minus 3.108. Now notice we moved the decimal point 2 places since 10 squared is equal to 100. So notice I moved it over 2 places. And then you'll also notice that I wrote the repeating part so that I wrote it so the repeating parts matched. So we had the 08 repeating in our original number. So I kept writing digits until I got the 08 repeating. And it's really important, if you did it right, you'll notice that they're in the same position. So here, they're at the 100th and 1000th place. And they should always be at the same place as each other. When I subtract those, I get 307.7. And notice the repeating parts canceled each other out. That was the whole point we did this. So the 0.08 lining up with the 0.08 repeating, those lined up so they canceled each other out. That's the critical key part. Now, we're going to get D, which is 10 to the p minus 1. And if you remember, I said if there's 2 decimal places, then that means we're going to have 2 nines. And the reason is we get 100 minus 1, which is 99. Now we need to simplify the fraction 307.99, which that has a decimal in it. So I'm going to multiply both numerator and denominator by 10 and get 3077 over 990, which is not reducible. And so that's actually our final answer. Let's take a look at another example. And this time, we're going to not do it so robotically. We're going to kind of think about it a little bit more. So here's an example, 0.8725. And you'll notice that 3 places are repeating. So what we're going to do is we're going to write 8725 and then 725 again. And notice, I've written it out so that way the repeating part is twice. And then underneath it, I put the repeating number, so that way those 2 repeating parts cancel each other out. I put the decimal point in the denominator, in the bottom, and I put the matching decimal point up on top. So that way we get 872.5 and then the repeating part minus 0.8 and the repeating part. And then when we do that subtraction, we get 871.7, and that's over 999 because there's 3 decimals repeating, 3 places repeating. So we have 3 nines. And now that one is still not good because there's a decimal point in the numerator. So that's definitely not good. I multiply numerator and denominator by 10, and I get 8717 over 9990. All I did was move the decimal place 1 over, and I had to add a 0 in the denominator. And that one is also not reducible. This next example we're going to look at is reducible. So I wanted to show you an example where you could reduce it. So let's take a look. We have 230.230 with the 3 and the 0 repeating. So 0.230. So I'm going to write out 23030. And notice that repeating part, I write it underneath. Now, all I need to do is add the decimal point for the denominator and match the decimal point for I keep calling it denominator. It's not really the denominator. The bottom number, and then I'm going to match the decimal point in the top number. So that way they line up. Our decimal points are looking really good. I subtract and I get 22.8. So now I do 22.8 over 99. And if you remember, 99 is because there's 2 decimal places repeating. So we have 2 nines. Now I need to get rid of that decimal point first. And so that's 228 over 990. And now notice they're both even. So let's divide both numerator and denominator by 2. And so that's 114 over 495. And I look and I say 495 and 114. Using divisibility rules, I know that they are both divisible by 3. So I divide the numerator and the denominator by 3, and I get 38 over 165, which is as far as I can reduce it. And if you check on your calculator, 38 over 165 is equal indeed to 0.230, repeating part on the 30. Couple things to note. If you do put it in your calculator, sometimes it rounds the very last digit. So usually in a calculator, we try to ignore the very last digit on really large decimal numbers. Another thing is, if you don't want to convert the whole thing into into an improper fraction, then what you need to do is just remove the whole number part of your repeating decimal before, and then just append it back on. So this one here is less than 1, so it won't be an improper fraction. That's about it.